Okay, it's 1 p.m. and it's time for our lunch hour special. Every Thursday, we come to you live with a session of free training, free session. My name is Paul Erubami, and it's my pleasure to be anchoring today's FM lunch hour. From wherever you are listening, from whatever platform you are in, it would be nice to have your name and your location. Just put your name and location on the chat so we get a sense of how widely our reach is. So we get to see who we are reaching. And if at the end of the session you gain something valuable, we expect something in return. Join by liking and connecting with us on our social media pages, LinkedIn, Twitter, Facebook, Instagram, and also join our Telegram group. We'll also hope that you would stay connected with our content. There's so much we're putting out on a daily basis. And now that we are preparing for the batch 19 of the Facility Management Mastercraft Diploma starting in August, specifically on August 7th, we hope that you will join us if you haven't gone through the program before now. Today we are starting. Last week we introduced the financial management series. We did cost effectiveness, all that those issues that have to do with how to manage costs. Other items from that series will be coming to us in subsequent weeks. Today, we're also starting with the Sustainability in FM series. And today, we're looking at energy management. There are 8 categories of sustainability, and the triple bottom line, there are so many topics we can bring to you in this Sustainability in FM series. But today, we want to look at effective energy management. Now, as a preamble, I know that the moment we get into full deregulation of the petroleum industry in Nigeria, especially with the recent subsidy removal on the price of petrol, what many people start thinking about is the impact on the individual. Oh, I'm going to have to pay more transport to get to work and to go to where I'm going. All the prices of food and other things are going up. And so we get so concerned, and the next thing is clamoring for increased salaries, and even employers are all thinking about, yes, we need to increase salaries, but you know what? If there is a crunch on the business will choose between retaining you to increase their salary or letting you go, or folding up itself, right? And so I think the last thing the business will want to do is fold up itself. So what we're doing is looking out for fantastic, innovative, creative people who are solutions providers who know how to save the business because they're committed and they're loyal, and then they will take those ones in so an inner caucus and let all of us go. Because they are under pressure to increase salaries and wages, they can't keep everyone else who's not being useful. So if you are in a job today, or you are looking for work, this lesson is very important for you, because if you learn the things we are sharing here, you're going to show so much value that no employer will let you go, even if they have to let go 80% of their workforce. You will be the darling that will stay back, right? And you will get a raise just because of the things you're going to be learning in this session today. So for you, I say, sit tight. You're going to be learning a lot. And organizations that have, employees who are in this session today, you're going to see, even in the midst of this cash crunch, you're going to see a marked improvement in your revenue, because there are so many areas that your revenue are entering into, that you will learn how to close those loopholes and increase your profitability as a business from today's class. So we get right into it. So that's about me. For those who have not met me before, I have experience in managing facilities, across the country and globally. I lecture at the University of Lagos, Masters in FM program. I'm an IFMA instructor for all of the IFMA credentials and certification, including the CFM. I have, certifications from MRICS, IFMA, and the CIWFM. And I've worked for large organizations managing some of the biggest FM portfolios in this part of the world. So I bring all that to you in taking this lesson today. So I'm going to just go straight to the energy. I told you I'm going to have different series in this. So I'm going to look at the triple bottom line and all of those sustainability areas, in another lesson. Because of the lunch hour being a compact session, I would like to go straight into energy. For us, energy is the fuel, is what runs our lives. Okay, so our productivity, our output is directly proportional to how much energy we use. So if you are doing a lot, if you're producing a lot, if you are achieving a lot, you're using a lot of energy. Pure and simple. So we are not trying to say because we want to manage energy effectively, you should use less energy overall. No. We are talking about energy performance. Energy performance refers to a metric that defines energy use per output, energy use per energy load driver, right? So those are the kind of things we're talking about. And then we also want to focus on the environmental impact of energy, because energy is sourced from both fossil and renewable sources. The fossil energy sources are the ones that deplete natural resources and also degrade the environment. And we want to be careful how much of those we use. We can't do without it right now. For example, we're transitioning from all of this dependence on crude to a lot more focus on gas. And at some point, we will probably move into more sustainable options like hydro dams and nuclear and vegetable sources of energy. Now, so what should our focus be? So the first item, better use less, not use less overall, use less per output, per driver. All right. So if I have a mall and I'm measuring my energy use, if the visitors to my shopping mall is increasing, which means we are making more sales, then I should use more energy. But what I'm tracking, what I'm working on as an FM is not to curtail total energy use, but to curtail energy use per footfall, per person that comes into shop, right? So how do I manage that? I have to have two numbers in place. I have to know my total energy, and I have to know my output, which is the people who use the building and those who visit the building, right? I want to look at the sources of energy so that I can focus more on renewable than the fossil ones. Use energy in a more socially and environmentally responsible manner. Understand facility energy consumption and purchasing. Improve energy efficiency of your core building system. We'll talk about this in a bit. Optimize facility energy use. Involve occupants in energy initiatives. You cannot control all energy losses in facilities. People that use it directly on a day-to-day basis need to be involved. And then we'll talk about heating and cooling loads. We'll talk about core building systems, your HVAC, electrical, plumbing systems, and all the other systems in your buildings. Now, so there are many energy saving options, right? For people who have been involved in energy efficiency, you will have come across ideas around energy lighting systems, reducing the energy the lighting systems, variable speed drives for your air conditioning system, and sometimes for your motors, like pumps and the rest. Building controls, building management system, that gives you visibility to how energy is being used. Intelligent lighting solutions like motion sensors and others that are built in to help you automatically put up lights when people are not there. Power management solutions, supply voltage optimization, combined heat and power for generation, where you use some of the heat that's produced from your generators to generate energy again, and so on and so forth. But your starting point, your number one energy saving opportunity is in what we call energy monitoring. You cannot begin to talk about energy efficiency, energy management, when you don't have visibility into how energy is being used. So that's number one. And these have been supported by several reports by large corporations doing research into how we use energy. Energy that is produced and wasted right now is almost 40%. And that will be higher for a country like ours, where we have very little in terms of detailed or disaggregated monitoring of our energy use. Many of us know what is being used at the facility level, the whole building, or maybe at the floor level. We have that bill, or that reading that we go take. Some of us even have check meters, and we say we looked at the check meters. But your energy use, you need to understand how it is used from time to time by equipment, by space, by user in your facility. That will give you the highest savings opportunity efficiency. It helps you change your plant behavior. It helps you pick out areas where there's invisible energy waste. It helps you to tune building control. So when you have certain building systems that are probably overproducing or overworking or working into times when nobody's in there, you can see that from the energy use pattern. Optimize existing equipment. Sometimes your equipment requires retooling, retrofitting, certain maintenance, and if you've not done them, the equipment begins to draw more energy to just stay running. So optimizing your existing equipment, verifying new technologies. So whenever you're going to switch from fluorescent or halogen, for example, to LED lights, you need to have a means of monitoring that circuit, so that you can say this is what it was reading or consuming before I switched, not just using the nameplate rating to make those calculations. You cannot make those from looking at the nameplate ratings. Automating meter readings, so being able to know exactly how much bills should go to which person or customer, or even just being able to pick in all the data related to how energy is being used for air conditioning, for lighting, for pumping, for all the things you do in the facility. It's very important that you have a sub-metering system. And nowadays we no longer depend on bulk check meters. We have IoT sensors, Internet of Things sensors that can be installed just at your panel, little logs that are attached to the cables or fuses to read the energy that is running through them, and you can have them presented to you in an app or a software or a web interface where you can see real time. It is 1:15 in the afternoon. I can check to see if the chiller unit in a certain conference room or event hall in Magodo is on when I don't have any booking for that event room, for example. If I don't have a booking for this time and that chiller is on, that means I am paying some money, because when the bills come at the end of the month, I'm going to pay, right? But I can check now to see that that is not supposed to be on. Put a phone call through to say, hey guys, what's going on? Why is the chiller on? Right? A lot of things I can do. I can from my own bedroom check to see if my security guards are, coming to the reception, chill in the night and put on the standalone AC units to cool, and in the morning they come out and pretend as if they've been on watch or guard all night, right? I know, from that kind of data. So in essence, I will no longer be having guesswork as to how my energy is being used, when it is being used, what device, what asset is using it, and what I am getting in return for such use. All right. All right. So let's get into some more specifics. The first thing you need to look at when you are concerned about energy and how much it's costing your organization. By the way, if you save from energy, that money goes directly into profit, right? So now let me give you a trick on how to present this to management. If your baseline for a particular equipment or facility is 5,000 kilowatts, let's say 500 kilowatts per kilowatt hours per week, right? And then because we monitored it, you found some areas of wastage and you cut out about 30% of that or 40% of that. So you just saved like 200 kilowatts out of that. And so because you made some changes, you reorganized the schedules, you did some tweaks to the maintenance, you created some new processes. So the system now runs on 500 kilowatt hours per week. You don't go reporting, I just saved 200 kilowatt hours times how much is the kilowatt hours now? I think it's going to be averagely 100 naira, right? So let's say 100 naira per kilowatt hour. So I saved 200 times 100. Therefore, I saved 20,000. No, that's not how to report it. That's not how to report it. If you want to report it, you report it for 5 years. That singular act of saving 20,000 naira per week times 52 weeks times 5 years is what you have saved. Because every time you make a conscious effort to plug and make a change, right, and that change becomes institutionalized, you can use a minimum of 5 years to claim the benefits of what you have achieved. Okay, so that's how to report it. All right. So when you do your energy audits, you are looking at the different things that consume energy in your facility. All right. And so the lighting, you're looking at the nameplates of the lighting, the rating on the nameplate says, this is a 60 watts, this is a 100 watts, right? Which means so much. If I switch from there to energy saving bulbs, of course, energy saving bulbs reduces the energy you use, but they have mercury in them, which is a hazard in themselves and an environmental nuisance. So I don't want to do that, okay? Because I'll save energy, but I'll have an impact. I can talk about this in another time when we're doing the sustainability triple bottom line. But then I have the LED. The LED is an electronic kind of lighting that I can have little wattage drawn on my light with no side effect to the environment. And then what I now need to do is find out if the lighting we're having in terms of ambient or task lighting were adequate. If they're adequate, what do I do? And I'll make sure that my LED replacement also provides the same level of adequacy, because at the end of the day, you don't want to have a change that creates a negative impact on the environment, as in the case of the low energy bulbs, the ones that have mercury, or a negative impact on the people. In the case of LED lights, when it becomes too dim and people begin to fall over each other and get hurt, or begin to have eye strains and become ill because they're not having sufficient light. You don't want that to happen. So you create that balance. I take the measurements here, which is my baseline. I take the measurement of what I'm trying to introduce. I gauge it against the utility, the value that the people are getting, right? So in doing an audit, I'm saying I want to save energy, but I also want to optimize the utility that people are getting from the facility that I'm managing and the services I'm providing, okay? And then, so whether I'm going to retrofit, to upgrade, to improve, to replace certain equipment, they all come out of the data that I've gathered from the energy audit. So I look at my lighting, I meter them. I can't just look at the lighting and make a decision, right? I have to actually do a metering, a gauging of what is consumed. So I can use an IoT sensor. I do that for my HVAC or other building systems, even other facility equipment. And then for my building envelope, I want to know whether the building is putting a strain or stressing my air conditioning units. If your facilities are oozing out cold air, or the windows and doors or the surfaces are feeling cold from outside when your ACs are the ones trying to chill the inside, you can be rest assured that you are wasting so much energy because those compressors don't stop. They just keep working so deep. And so, you use your thermographic imagers to image, around major points around your buildings. And then you know that you now need to create some reinforcement. Sometimes you have to remove the whole windows in the facilities and replace them with thermal insulated ones. Because if you compare the cost of energy to the cost of the cost differential or savings of the cheap windows that you have put in place that is making you to lose so much, you probably want to let go of the windows, and cut your losses and then start saving on your energy. If your compressors are running and the interior spaces, reach saturation point to the temperature that you set it, that you want as your comfort cooling temperature, what happens is that the compressors drop, you save in energy, while fans with low energy consumption just keep circulating the air. When the heat builds up, the compressors pick up again. Let the heat build up be based on the users, because your energy is to provide comfort cooling for the users, not to cool the heat you are bringing from outside because of the building fabric or building envelope not being good enough. Also consider how your energy is purchased. If you are having your own dedicated transformer, your point load, you have a skipper meter or any of those kind of, the maximum demand metering system, be wary of your peak. There are certain things that are happening to your billing that you probably don't understand. There is a peak factor that is applied to your bill. You don't pay the bill, on the area under the curve. You pay the bill on the area under the curve plus a factor based on your peak. So you want to use shedding to shut down certain loads, prevent them from running during your peak period. If we have a mall, for example, and everybody comes into the mall at a particular time, that's when we have the highest footfall. We're not going to tell them to leave. No. We're going to look for things that don't need to be running at that peak and make sure they are shut off. If those items must work, right, but we can afford to move them from the peak period to the off-peak period, we call that load shifting. If you can shut them out and not do them at all, we call that load shedding. All right. So those are two techniques if you are on the the big levels, big consumers. Now, I've talked about some of the macro measures. I've talked about your building envelope. I've talked about your building system, HVAC, electrical system. And what I'll just tell you about these is any system that you have in place, you need to ask yourself, what is this system supposed to be given to me? So the utility from a air conditioning system is comfort cooling. Yes, comfort cooling. If it is comfort cooling that I need, if I see that system excessively vibrating, because it means automatically that the energy I'm investing in it is not only producing, converting to cooling. There's some of them going into vibration that I don't need, or excessive noise. Some of my energy is being wasted producing noise. Or I have an electrical system that heats up, cools down, heats up, cools down. Every time it heats up, it's energy that is being wasted in producing that heat. So in all of the building systems, you need to deal with those conversions of energy that create losses. And the way you can know is by metering. You can have an IoT sensor attached to each of these devices, know when they are normal and working okay, how much power they're pulling, and then when they now begin to produce noise, vibration, and all of those heat excesses, you now see how much energy they are consuming. The gap you need to measure and tell yourself, okay, if this continues for 1 week, for 1 month, for 1 year, how much will this be in terms of energy cost? How does that cost now compare to how much it will cost me to fix it? Sometimes you go to management and say, this building system is having an issue. We need 200,000 to fix it. No, they still working, leave it. There's no need to spend 200,000, right? But if you can come with a calculation that shows that you will be spending 200,000 every week extra on energy to be managing that 200,000 you don't want to spend, then I'm sure somebody will listen to you. All right. So other things that affect your energy use that you need to watch out for, poor connections and dirty connections. This is basically what happens with electricians. They don't want to use proper connectors. They cut and peel and twist cables. Those joints are not, very tight, and they can have all of those poor connection issues. You have undersized conductors, that get hot when the equipment is in use. Sometimes it begins to melt and can even lead to fire. You have low power factor. You have leaking installation. You have voltage imbalances from your three-phase, multi-phase connectivity. Think about all of those and fix all of them because they are costing you energy. So, coming from the standpoint of energy audits, you first of all do your survey, and then your audit will capture, clamp here and there, and capture data of your baseline. It will run for so you can run it for a 24-hour period that gives you your peak, per day. But if you run it for a week, it gives you a pattern around people's activities during the week, because there are some days that are different from others. Peak might be different in a weekend compared to a weekday, for example. So you get a sense of all of that by logging everywhere and gathering that data to get that information. So that by the time you begin to do your investigations into each aspect, for example, the first thing is you will see areas of your use, energy consumption, that are already deviating from their nameplate rating. So you have a pump, and the pump says it's supposed to draw 3.14 kilowatts, right? And when it's running, because you metered that particular pump, with all the noise and the heating up that happens in it, you are seeing 4.5 kilowatts in that reading. That already is an indication that you are losing 20%, 30% of energy that runs through that pump. And you can immediately have a calculation on all of those wastes. Look at how far they've come with that error, and look at how far they can still go in terms of cost going into the future. Because if you now make that justification and you get approval and you fix that item, you should be able to show for that particular one that the energy was actually saved. So that's why we don't advocate that you meter, you make a change of lights, make a change of ACs, and then you try to use your aggregate metering or your stop metering or check meters to know that the work you have done actually produced the savings. No, you must identify that the work you have done produced the savings in the area in that particular work that you did. All right, so that's a big area, but let's look at the micro area. Sometimes you think a TV being on standby, a printer being on standby, a laptop not going up anytime, always plugged in, or always having work on queue is not a problem. It is a problem for two reasons. All of those things consume energy, whether they're in trickles or sometimes they actually consume a lot because of background processes that are running in them. But in addition to that, they also produce heat. And that heat puts a pressure on your HVAC system. So you are moving energy in two dimensions when you have things on standby and running in your facility. All right, so let's go to some specific areas, within your facility. So lights, are lights on in areas that are not occupied? Are you using photo cells or timers for your light switching? Because if you depend on humans to remember to go and put off a light, The day they don't put off the light, then you lose money, right? And that can happen very frequently if you're not paying attention. Have you considered the impact of dirty lamps, dirt on your lamps, lenses, and reflecting surfaces? All of those deposits that shade the light are all part of losses, because you'll still be paying for the energy that that lights up that space, but your luminance is being reduced, right? There are some areas that are overlit, too bright. Sometimes that too much brightness can be both an energy loss as well as discomfort for the occupants. Sometimes the security lights, you just have those lighting systems that are set up outside for security. They are always on. There are ways to make lights in your setup, in your perimeter, to come on when it senses some kind of motion or activity. While there will be others that will not be too bright, that will be coming on just to manage the energy cost of your perimeter lighting. And then you have had certain light fittings in place for the last 20 years. The technology for making light 20 years ago is no longer what they're using for making light now. You have all of those ballasts and all of those engines inside them that, while the light is on, they're making some noises in the background and so on and so forth. Just move away, and you can do this in a low hanging fruit way, where you don't necessarily need to have a major investment, because they'll still die, they'll still go up. Like for example, they'll still go up, they'll still go up. You need to buy some of those, what do you call those things you put inside them, to replace the tubes every now and then. Divert or direct that maintenance replacement budget into a gradual phase out. So instead of buying fluorescent tubes and stocking and using them to replace any tube that goes off, I'll buy a set of LED lights, and then I'll change out a section of my facility with those LED lights, and then I have my reserve tubes from that area to be using to fix other areas. And when I get my next stock of LED lights, I go to another area, I take out all the fittings and their tubes that are still working, I keep them in stock, using them to replace the others while I put in LEDs. So my budget can actually be used to phase out gradually over a 2-year period without having any adverse effects on my organization. All right, so the electrical system, we talked about this already. You have to deal with a peak, load shedding, load shifting. Talk about power factor. If your power factor is very poor, you're wasting energy. Overall energy that you are using must be measured. What you want to have in your facility is an even out energy use as much as possible. You're not using very little at this time and very high at that time, right? So you're trying to remove all your loads to fill up those off-peak areas so that there'll be something even as much as possible every day of the week, 24 hours a day. All right. So unnecessary lights are turned off, your retrofit lighting systems, you shut down unneeded equipment, you implement variable speed drives for your motors, driving equipment, replace old electric motors with new and high efficiency motors, replace driven equipment running more energy with more energy efficient ones, and then for your air conditioning, think about the indoor thermal qualities of your air conditioning. When you have air conditioning in place, there are outdoor chillers, there are air handling units, your mechanical rooms at every floor, and you have ducting that runs through all of the spaces. And you want to ensure that your building is designed to be tight, thermally tight. You want to ensure that the ducting system holds on to its cooling, is not sweating all around or cold inside the roofing area, so the cooling gets to its destination rather. And then for fans and pumps, they use motors. These motors should be such that they can be improved with variable frequency drives. These are controllers that makes the motors not to run at a fixed frequency. irrespective of the load that's on them. It makes them to work according to what you are getting out of it, the value you're getting out of it. So all the noise, all the vibrations and other energy losses that comes from your motor use will be controlled. A lot of industries need to pay attention to this, especially those manufacturing industries where energy cost is sometimes running more than 40-50% of your energy use. Think about how to implement motor controllers that can help the equipment to work evenly and respond to loads. For fans, reduce forced draft fan and inducing draft fan power consumption by minimizing excess air level in combustion systems. Minimize leaks in and out of air conditioning systems. Replace impeller with high efficiency impeller along with cone. Downsize as needed by impeller, derating, and so on and so forth. What you are doing about fans, and if you talk about fans, many of us may not be very much aware, except you're imagining high-rise buildings. There are fans that help to ventilate columns, stairwells, and other areas in your facility. There are fans you have in your toilet that helps to expel foul airs and the rest. And then talking about pumps, we try to first save the life of the pump, right? So if you have a policy of pump arrangement where you have more than one pump in an array, you make them work intermittently so that one can rest and the other takes over. But even at that, you want to manage the pressure. Don't use it at the highest pressure. That way, it tends to use average energy. Don't oversize your pump. Ensure that the motors that are attached to your pumps are adequately rated as well. And then for electric ovens or any kind of ovens, any heat loss is a waste of energy, right? So you want to ensure that the doors, surfaces all around it are well sealed. And for those who actually use ovens, try to not put things that, if you put something that is too hot into a fridge, you give the fridge more work, right? Allow it to cool down a little bit before you put it into the fridge. If you put something that is too cold into an oven, you give the oven a lot more work. So allow it to defrost and settle in before you put it in. Some of those little hacks here and there saves you a lot of energy. And then your water heater. The thermostats are sometimes always turned to the highest, and so don't leave it at the highest, right? Set to the temperature that you really need, both for safety, from the safety point of view, and also the energy use. Because what the thermostat does is, if it heats up to that temperature, it cuts off power supply, right? So the water stays in the temperature. But normally that water will drop temperature over time, even if you don't run it. Even if you don't run water from it, the cold water goes to mix it and temperature drops, and then it heats up to the temperature you set it up again, right? And then if you don't need to use hot water, then why do you need to use hot water? Sometimes, I see some plumbing systems where they are wired the hot water into virtually everything, into sinks, into wash and basins, into all kinds of places, right? But pipe it into the areas where it will be needed. Really, there's no need piping it everywhere. And then if you really want to control your water heater use thermal switch for it. You go into the bathroom, there's power, you put on the water heater, you forget to put it off when you are leaving, right? But if you use a thermal switch, a 15-minute thermal switch, a 30-minute thermal switch, what happens is that, by the time you leave, it counts its way back and then it goes off, which saves you a lot of energy in itself. So instead of leaving it constantly on, being heated, cooling by itself, and coming back heated, you can save a lot of energy from that. Your chiller systems, retrofit and the chiller system with variable frequency drives. Many of us are beginning to install VFD systems nowadays, which are more modern, improve efficiency of the pump, lower the chiller condenser water temperature, So usually when you use the refrigerant to chill the water in the chiller, and you run that water into an air handling unit that is, blowing the air that is moved in. The air gets cooled and is moved in to get circulated within your spaces. If you manage how cold you get that water, you can get more air instead of cooler water, because you always have that balance between more air that is at a certain temperature and less air and colder water. It gives you the same effect when they come in. So you want to manage the cold water, because that's where your compressors are really being kept busy, all right? And then upgrade them when they are old, because usually chiller systems will last you some 25, 30 years and they are still working. But in that time, the energy efficiency would have dwindled significantly, and there are quite a handful of options for retrofitting them, whether it's the control or is the compressor or the air handling unit aspects of them. All right, so that's a run through of energy efficiency, energy management for you. I would like to hear your questions. Let's have a discussion. I want to see who's interested to ask a question. I'm focusing on the Telegram app. All the others in the other platforms, if you're not able to drop your question on Telegram, drop it on the platform where you are, and the team will get it through to me on the Telegram app. I hope this has been helpful to those of you who are here. So let's hear your question. And if you have anyone who missed any of our launch hour sessions, just direct them to our Facebook, Instagram, LinkedIn. You'll find them there all the time to revisit and watch. And the team will also ensure that we have a recorded version brought back and placed on the Telegram group before the next class, so in fact, before the weekend. Now, you probably are wondering where all of this training content are coming from. They're actually live content coming from our Facility Management Masterclass Diploma. This is a training program that we launched about 6 years ago, and has trained more than 500 people as professional facility managers in Nigeria. Yeah, we have reached more than 1,000 individuals with free content like the one we are part of today. The next batch starts on the 7th of August. Registration is already on for this. We have capacity for just 100 on the virtual program and 50 on the physical class that holds on Saturdays. The physical classes hold on Saturdays from 10 a.m. to 4 p.m. and the virtual classes hold during the week, Mondays, Wednesdays, and Fridays, 5 p.m. to 7 p.m. All right, I'm giving a few more minutes to see the questions as they drop in. If you have a need to get specialist support with your energy audit, please call on the Max-Migold team. Just put a note in here. Any member of Max-Migold staff will contact you and will do a free survey and give you a proposal for energy efficiency. we guarantee you a savings of at least 30% of your energy consumption, your cost, in the first year of engaging with you with your energy efficiency. So just think about what 30% means to you, because that's a percentage. But for some organizations like universities, they spend more than 100 million, for example, in energy per month. So that's 30 million saved. For banks, for industries, for manufacturing plants, they spend even more than 100 million sometimes on energy to run their operations. And what this means is that the savings that you can get from our engagement in the technologies, in the monitoring, in the retrofits, and all of the things we're going to deploy for you can come out of your savings. So you don't necessarily need to even have a budget for energy efficiency or savings. You can get all your savings accomplished, take care of the cost of that investment. All right. So if 30% of your operations today, in terms of energy consumption, it's already say 1 million naira, for example, or more, then you don't even need to pay for energy efficiency. We'll do all the work, we'll save all the money, and we'll pay the cost of improving or saving your energy consumption through the implementation of energy efficiency. All right, so the first question here says, at what point do we need to audit energy in your facility? It's like saying they're trying my house. When should I go for the fire extinguisher, right? Ayola, the truth is that you need to know right now where energy is being consumed, how energy is being consumed, what each element of your facility or component of your facility is doing with regards to energy consumption. You need to know right now. So it's not there's no time in the future that is more appropriate than now to know. It is only after you know. So if you do an energy audit, we install all of those sensors and meters to gather the data. I will give you a report. We expect that as you are implementing those improvements and those changes, you don't say, oh, we've done the audit, take your equipment away, we just rented it for a while, there's no need for it. No, you need to have those systems in place as an energy management or energy monitoring system, so that going forward, as you make a change, you will see the impact on that micro area and in the aggregate bill. As you make another change in another area, you see the impact, right? So you're going to be seeing those impacts because you have an energy monitoring system installed across your facility. All right, so it's actually better you do it as soon as you take over the facility. As part of your facility condition assessment, you put in your energy audit to give you your baseline energy profile. So that by the time you begin to do all of those improvements, changes, upgrades, retrofitting, and monitoring, you'll be able to see what your impact or contribution is to the energy use and cost of that organization and that facility. All right, so I'm expecting one more question. I'll take that one and then I'll call it a day till next Thursday when I come to you again with another topic on the FM Launch Hour live every Thursday. And please inform your friends, inform your colleagues your technicians, your cleaning supervisors, security supervisors, and associates from across the built environment, builders, construction teams, real estate people, estate agents. Invite them all here. Let's learn together every Thursday. Facility management is a growing profession and requires all the hands that we can get. Yes, get to know if remote working can be classified as a way of managing energy for companies whose parts of operations can be done remotely. That is a fantastic idea, yes. But again, when you talk about remote working, it doesn't mean that energy will not be used where the work is going to be done. So if the company wants to save the cost of energy of comfort cooling, electrical energy supplied to the device or equipment that staff be using, if that staff does that work at home, will the company also pay the staff enough to cover for that energy is going to use? Because if you shut your house down and go to work, you're not consuming energy. If you're doing the work at home, then definitely energy is going to be consumed, right? So it will be energy saved from one party and transferred to another, right? But yes, companies can say, you know what, let's do remote work. People work from home and it will save them a lot of energy. Yes, that's good. Remote work is not a bad idea. Many companies tried it, enjoyed it a lot, but we expected companies to stick with remote working and because of all those savings and benefits and the rest. But companies also realized that they were not getting as much as they hoped in terms of productivity, commitment, and loyalty from remote workers. And that was why many of the large corporations moved back into the offices and stopped all form of remote work because of human nature. People just ghosted on their bosses, when working remotely. Many of them just took up other jobs, got engaged, freelancing on so many projects, ended up not being able, in fact, they breached the terms of their contract with their employers, and that became a big issue for remote work. If you can have very honest workforce, then remote work is supposed to be a good idea. Even when you put in a remote work monitoring system that monitors engagement with platforms and the keystrokes and all of those monitoring systems, staff still found ways to bypass them and do very little work in the name of remote work. So that's a concern, all right? But so if you were taking that remote work option, the expectation is that you're saving on your transport and commute. Therefore, you can take care of the energy cost from your end. The company will save that cost, save the real estate cost for reduced real estate. But then the company also needs you to put in a full value for a day's work. Okay. Where can the beginner start in the FM industry? Get the training, get the qualification. So if you have just left school and you want to go into a profession that in 2-3 years' time you will earn up to twice what your classmates will be earning in the whatever you study discipline, FM is it. Come to the FM Diploma. Go straight to promo.facilitymanagementcourses.com and join the August batch, the 19th batch of the FM Diploma that has trained more than 500. That is the beginning. Many people start their careers in FM with very, very low salaries. They leave school from NYC, they start off at the 40,000 Naira job. They go from there to 50,000, and they've been doing this for 5-6 years. They are still in 60 and 70,000, right? But once you take the FM Diploma, it's quite an investment, considering where you're standing with your low earning. But if you take it, within 2 years, you will be double. So instead of the salary going from 50 to 55 to 65 to 75, you automatically see yourself at 100, 120, 150, 180, 200, right? So that's exactly how it works, because the demand for skilled, knowledgeable professionals in the FM industry is very, very high. It's very, very high, because there's really no stock of people qualified to run it. There are still a lot of opportunities for people who don't want to train, who see the cost of training as an impediment And I thought they struggled for years in that 50,000 to 60,000 naira salary range for a very, very long time. Many of them come back after 4 years to the FM diploma, only to find out that people who left school, few years after them have already risen higher than them in the FM industry. So don't waste that time. The difference between a 60,000 a month salary now and a 200,000 a month salary in 1 year is huge. It pays 3-4 times the cost of taking training. So just go straight to promo.facilityManagementCourses.com and join the batch 19, and that is your starting point. It is something that is going to get you on the front footing. You will never go wrong with it. Okay? All right. So that's our lunch hour for today. Thank you for being here. Thank you for participating. I'll see you again next week, Thursday. Bye-bye.